Hello, can you hear me? So, please grab your snacks and drinks, find a comfortable seat, and we will start the meetup. So please join us in the all hands area. Let's wait a little bit. So great to see lots of people joining in. Hello, hello, hello. I think most of you have grabbed some snacks and found a seat, so welcome to Pipedrive Tallinn. But before we carry on, before we go on, I can see some familiar faces in the audience, but lots of new ones. So out of curiosity, how many people are here visiting Pipedrive for the first time? Can you please raise your hand? Ooh, nice. Welcome to Pipedrive. So excited to have you here. We have a very, very special meetup coming up. There's a clue already on the screen. So this is the first ever user group, AWS User Group Estonia meetup taking place. And also, this is the very first meetup taking place in this building over a long period of time. It's the first one here in Tallinn this year. My name is Maia-Liisa. If I'm not hosting events, I do work here at Pipedrive. I'm very excited to be with you. And let me tell you a little bit before Pipedrive, before we go into the conversation. So, I like numbers. Pipedrive was founded in 2010 by 5 Estonian guys. So we have been in the business approximately 14 years. But this particular office building has been home to Pipedrivers approximately 5 years. So we moved in here in December 2018. And we have around 300 people working in this building. What's cool about Pipedrive is that, Pipedrive Tallinn, is that we have so many departments presented here in this building. So if you work here, then you have lots of bright minds from different functions, different departments that you can collaborate with. All in all, we have 10 offices in 8 countries, but this building is actually the biggest one. So in terms of physical size, but also the number of people. And I'm really, really hoping that by the end of today, maybe someone is interested in working at Pipedrive. So please do check our job openings, but I do have a but. There's one thing that they don't tell you when you apply for a job at Pipedrive. And this is the reason. So when I joined Pipedrive, I signed a contract, and approximately a week later, my manager, who is also somewhere here, not mentioning names, she told me that, hey, so you get great colleagues, great work, a great salary, but also plus 10 kilos. So this is what you sign up when you come to join Pipedrive, because we have always something great to celebrate here. Is it a birthday, anniversary, promotion? There's always too much kringel, this sweet pastry, but also lots of other stuff here. So be aware, this is something that they don't tell you in the job ads. But it's getting a little bit lonely here on stage, so let's kick it off. Let's start this journey. Our very first AWS User Group meetup in Estonia. If you want to join the conversation, and I really, really hope that you do, then there are several options how to do that. the live audience has the opportunity to ask questions live. So we will have a green microphone moving around here in the room. But also you can join Slido. So either use the QR code or use the password. So buckle up, let's start this adventure. And we couldn't have done this meetup with one very, very special person. So please join me on stage, Štěpán, and give me a warm welcome celebrating Štěpán.
Thank you very much. I have just one slide, so I probably don't need the clicker. Thank you very much. Hello. So before we start with all the talks we have for today, just please give me 5 minutes of your time. I would like to tell you who am I, why I'm here, and what are the next plans with the AWS meetups in Estonia. So very quickly about myself, I'm Štěpán. I am actually working in, let's say, like 2 companies right now. First one is called Revolgy, and Revolgy is AWS partner helping companies to get settled in AWS and make things easier in AWS. I'm leading the GameTech department there, so if you like games and cloud, please reach out to me, I will be happy to talk to you. I have also a small startup called Remangu. It's connected with my activity in Revolgy, and it's a platform basically enabling game developers to work remotely, if I would simplify it in one sentence. Okay, but let's stop talking about me. Why I'm here, how I get here actually. So I'm from Czech Republic. I think I'm the only one, well, together with Miguel, not being Estonian on stage today. And I moved to Estonia about 5 years ago. And when I was living in Czech Republic, we were organizing quite nice cloud native computing foundations meetups there. And I like it. I was part of the organization team. And when I moved here, I wanted to replicate this activity also here. But then what came was COVID. We maybe already forgot that it was here, but like it was here. And the whole idea, went on hold. And for a couple of years, unfortunately. But then last year, I talked to my friend and colleague from AWS from the Helsinki office. And she said, look, like in Finland, we have 4 different AWS user groups happening regularly. In Estonia, there are like a lot of unicorns, a lot of startups using AWS. We have nothing. Would you like to do something about it? I was like, well, okay, why not? Let's try it. And because we, as Revolgy, we don't have any huge presence in Estonia, I knew that I will need some help and I will need support, from local companies. So I reached out to my friend Yuri, who is over there, and he connected me with the right people inside of the Pipedrive, inside of the Dynatrace, and the ball started rolling. It took a couple of weeks, and today here we are. So big thanks to Pipedrive, mostly Dynatrace, to Wise, AWS, of course, and all of you who came here in such a huge number. I am very positively surprised that it's a big attendance here. Thank you for that. And last thing, very quickly, what are the plans for the future? So if it would be possible and if you would like it, I will be more than happy to help convert this into regular activity and not end only with the first meetup that we are doing today. So please, if you have any ideas, if you would like to participate, if you would like to be next speaker, if you would like to let me know what topics you are interested in, please connect with me either today or I hope that the QR codes actually are working. And yeah, we'll be happy for any help and any feedback. The idea is to, let's say, do also the next events or next meetups in various offices in Estonia, in Tallinn, or maybe also in other cities here. And we already have 2 interested companies who maybe would like to do the next one. It's Dynatrace and Wise, so speakers today. So let's see. I hope that we will see again. I know we're just starting, but I will see again probably after summer. Thank you very much again, and enjoy the evening. Okay, and now I will invite to the stage the first speaker, Miguel from Amazon Web Services.
Hi everyone, nice to be here, nice to see so many people. Looking forward for the sessions we're going to have today, thank you. And to learn as well. So I'm Miguel, solution architect based in Helsinki. I've been with AWS, I've just completed 5 years with AWS, and currently my focus is independent software vendors, so software companies who build SaaS solutions on AWS. So to get started, okay, this was where I should introduce myself. So these are some logos with who we work. You might recognize here in Estonia, but also more broadly in the Baltics. And there are, of course, more companies that are not publicly kind of sharing that they work with us, but these are some well-known logos. A lot in fintech, we have some startups, we even have public sector. So yeah, really good place to work with, very competent people. We enjoy a lot. And so we have been increasing our presence in events as well. So these are some of the events that we have either participated, well, in this case, these events that we participated in. So at the top, the biggest ones based on Estonia, except TechChill, which I believe is based in Latvia. We're going to be present at Latitude 59, and then some smaller ones, including the Drupal conference that I was presenting at last year, or 2 years ago. So we also started organizing. We are increasing our presence here. We just organized last month a financial services symposium where we had over 60 people. I don't know if any of you joined that. And we had specialists flying over from AWS to present there to financial sector companies mostly. And we are also coming now, as I mentioned, to Latitudes, and we're going to have a generative AI-based workshop there. Another thing that might be useful, I don't know if you want to use that barcode, we have an experience center currently in Helsinki, that's the closest. And if you follow this link, it will show you the events we have in Helsinki and in Tallinn, actually. So there is already starting to appear some. And these are typically hands-on workshops that are free to participate. You get AWS accounts and you can experiment in any of the topics. So a lot on data, platforms, of course, generative AI, databases, whatever. You can follow this link and see which ones are coming up in the next months. But we will have many more by end of this year, so we have big plans for Estonia. I cannot yet disclose, but yeah, you will have even bigger presence of AWS here. All right, now a bit on the technical side, and we mentioned generative AI. So this is a big focus of us at the moment, and many other companies as well. We are having next month the Stockholm Summit, which is in the Nordics kind of the biggest AWS conference, where I'm actually presenting there, and most of the tracks have like a taste of generative AI, large language models. So it's a really big focus now. So I just wanted to bring this up and talk about what we call the generative AI stack at AWS. So first thing you will see increasingly is that our tools, the console, our business intelligence tool, QuickSight, and others, they are being imbued with these generative AI capabilities. So more and more you will see these chatbots that you can ask questions. How do I create a dashboard in QuickSight? And it will spit out the code that you need to add. We also have Amazon Q for developer, for coding, helping to code, refactor code between different languages. Even there is a thing called Amazon Q Developer Agent, which will actually do commit kind of a pull request and kind of do the whole thing. It's kind of an agent. So it not only chats to you, but it also does stuff and then commits stuff to your repositories and so on. So these are typically under the umbrella of Amazon Q, all these functionalities that we had on top of our services. But then when you want to build your own generative AI-powered applications, then you look at this middle layer, which is Amazon Bedrock. And Amazon Bedrock, in the essence, it's like an API through which you can access many different models. So you can change very quickly. It's the same API, and you have private access from your AWS account to invoke these models. It also supports some of the most common workflows, which are the agents in one side, and then retrieval augmented generation on the other hand, which we call knowledge bases on Amazon Bedrock. So it's kind of helping you get started with those workflows. But in essence, it's an API with which you can use to invoke different models. And then at the bottom, it's the support for all these things. We need infra, right? So we need the GPUs. We have a huge variety, not only of NVIDIA, the latest NVIDIA GPUs, but also our own GPUs. We have an SDK called, sorry, I'm covering it, an SDK called Neuron, which is kind of like CUDA for our custom silicon, which is Trainium and Inferentia. So they are more cost-effective machine learning GPUs. Yeah, so that's kind of the basis that supports everything else. So talking about the models, so as you see, this is evolving very fast. Our approach is that we don't favor a particular model. We have our own family of models called Amazon Titan, but we offer from many other vendors behind the same API. So you have both open source models like Llama, Mistral, but then you also have proprietary models that are still hosted on an AWS account, a so-called escrow account. And you are guaranteed when you use these models that your data is not leaving AWS, is not leaving your network. The model providers themselves, they cannot see your data, so it's a secure environment for you to test these models. And there are models for text generation and chat, for image generation, for image understanding. So you can ask the Claude 3 family of models, it actually understands images. So you can ask it to reason about diagrams or pictures. What is this picture showing? And it's pretty incredible. It also does OCR, and it's pretty good at that. And Amazon Bedrock is evolving very fast. So I just wanted to highlight 3 announcements that were recently launched. So Amazon Bedrock Studio is kind of an integrated environment that you can access through Amazon IAM Identity Center, so single sign-on, direct access to the Studio IDE-like environment where you can build your Gen AI projects. So it's kind of bringing all these things together in one UI. We also launched the capability in knowledge bases to, without this RAG type of workflows, usually you requires a vector store. You need to chunk a document into parts and then embed it and then retrieve from those vector stores so that you can ask questions. We now offer a possibility of just uploading or just sending in an API request, one single document, and ask questions about it. It can be up to 20K tokens at the moment, which is about between 30 to 60 pages of text. So for example, if you have a very complicated, insurance policy, you can send it to the API and ask, am I covered in this situation, for example? So it's a nice functionality. And finally, custom model import. So behind the same API, you can now not only access all these models, but also bring, if there is a model that you find open source on Hugging Face, for example, you want to bring it behind the same API and access it in the same way, you can do, well, it's still in preview, public preview, but you will have access to this custom model import on Amazon Bedrock. So you can import the model weights into the service. All right, now a bit of, so we talked about the technology, just a bit of inspiration regarding machine learning and use cases. So at Amazon, we created this thing called the Packaging Decision Engine. It's not a new thing, it's just been evolving. And this exists since 2015. So basically, we have a huge, as you know, inventory of items, and we need to somehow find the most efficient way to package without breaking those items so that they survive until they get to the recipients. And so we need to find a way to, to decide very quickly and think about it. The inventory is always changing. It's not, there is all the time new types. It's not easy just from the description or just from the name of the item to understand what kind of packaging it needs. Sometimes, and we do offer now, the item doesn't even need any box. It's already in its original packaging sent to the consumer. So in the US, I don't know if my sound is still working. Yeah, cool. In the US, they already do that. So in some cases, you don't need an extra box. Just whatever. The item is already packaged. So you just send that to the recipient. So to do that, we employ machine learning because it's impossible to do this manually. And we have so-called a vision tunnel through which all items pass. It looks for defects in the items, but also checks if the item is maybe foldable, what kind of texture, does it have any glass or any fragile parts. And it uses that as an input to the decision of what packaging type. And of course, this is there is a feedback loop there. So you send a certain item with certain image, image embedding, and certain text and category of the item. But then it might be returned because it was broken, so that goes into the retraining or continuous training of this decision engine. And with this, we actually managed to reduce the number that is put forward is of I don't want to get it wrong, 2 million tons of less packaging that was used thanks to this decision engine. So yeah, things you can do. This is not generative AI, it's not large language models, but it's deep learning is involved there as well. My last slide, I don't want to take anybody out of Pipedrive, but actually we are also hiring at the moment in the Nordics. Unfortunately, not yet here in Estonia, but in Finland, in Sweden, Denmark, Norway as well. So we have positions open. If you know somebody who doesn't mind relocating and would like to apply, just contact me, and I think we have about 19 positions just in Nordics and Scandinavia. That's, I think, all I had. So the next speaker is Christian. Thank you. Yep.
Just in case, does someone have a question to Miguel in the audience? Or in the Slido? I do have a question for you. So, a very visionary question. What's the future of AWS in the near future?
Well, that's a very... I wasn't prepared for that kind of question. Well, I think the future is for sure also here. I think that's what I wanted also to convey here, is that we are betting in Estonia and in the Baltics in general. I think you will see a lot more activities from AWS here in this region as well. And hopefully also customer base is growing. Thank you.
Thank you so much. As you can see, we have next up our own Pipedrive's Christian, so give him a warm round of applause.
Hello, microphone works. Welcome everybody to Pipedrive. My name is Christian. As already mentioned, I am the Director of Engineering of Infrastructure here. And I will be talking about how Pipedrive migrated from a private cloud environment into AWS or a public cloud environment. This was a huge project, multi-million dollars, took a lot of years, so it's a lot of content, so bear with me. And when we started this journey over a year ago, I was thinking that probably would be cool to speak about it after it's done in some kind of an event. Well, and here we are. So, to start off with and set the scene, I saw this picture a while ago and thought that that's so true, and teaches you to keep yourself humble, and certainly it has taught me. So, the agenda for my talk is a bit about me and Pipedrive, our tech stack, and how we have been hosted. A thing called megaparsec, I will explain, and our region architecture, planning, migration, a bit about costs and visibility of costs, and what are the success levers that helped us to complete this, and some questions and answers. So about me, there's a LinkedIn link there if you want to scan it. I've been in Pipedrive since 2015, joined as the 4th infrastructure engineer, and currently the infrastructure team is 26 people. We have infrastructure engineering, database engineering, observability, platform engineering, and architects in my department. I've been the team lead since 2017 and head of the department since 2019. And how small is Estonia? Next speaker, we went to school together in IT college and worked in Swedbank together, and the speaker after him is my wife's brother's good friend. And a bit of a caveat for my talk as well, if you see some funky colors, then I'm what they call a color confused. So, my fault. On my free time, when I go on vacation, I like to do some of these things, which apparently all require a lot of clothes. I don't know why. Right, so Pipedrive, Maielis already said, founded in 2010. We are a SaaS CRM application, and it was built by 5 Estonian people working, some of them in sales. So sales CRM for salespeople by salespeople. And we have been an AWS customer since the beginning, so actually from 2010. Our tech stack, some basic principles that underline us. So we have a multi-tenanted architecture, which uses containerized microservices. We have a architecture or structure where we host one schema per customer, one database schema per customer. We started actually with one. Nowadays it's already, I don't know, 5 or something. And there is a Medium article there, which describes this architecture a bit more. We use infrastructure as code, and we use third-level domain for our application. This is important for a reason that I will explain later. Besides that, we also, it's not a principle, but we have tended to build all of the infrastructure solutions ourselves, not to use managed services. This may be changing in the future, but this is how we have done it. Tech stack. We use Node.js, Go, and legacy PHP in Pipedrive. So these are the microservice architecture with these languages. We have 2 in-house boilerplates, or these base frameworks that help us to create new services quickly. We have over 750 microservices across Pipedrive. We host these in a Kubernetes environment that is powered by service mesh and then has auto-scaling and is deployed by Argo CD. We have a lot of infrastructure-based services that we host next to Kubernetes. Biggest one of these is MySQL. We use Percona flavored MySQL, and this is about 1/3 of our infrastructure. That's why also this schema per customer is important. We have our observability platform is also hosted in-house or by ourselves in AWS, and we use the Grafana offering or the LGTM. Cloudflare is our CDN provider or routing provider as well. We use IBM Consul and Vault soon, and Ansible and Terraform for our infrastructure as code. A bit about how Pipedrive has been hosted. So since before 2013, there was different times. So it was some Rackspace public cloud, some other funky solutions. But since 2013, we have been hosted in Rackspace private cloud, which is an OpenStack environment. And what OpenStack is an open source cloud project started in 2010 by NASA with Rackspace to to help them host their cloud environments, or their actually local environments. We had steady growth from one data center in 2013 in the US. We had 6 compute servers and 1 Cinder node to begin with, 1 Cinder being storage node. And remember at the time, me and my colleague, we were really praying all the time for the 1 Cinder node not to die because there was no redundancy. But by 2017, we had already 25 compute nodes and a software-defined storage system called Ceph. Now, Pipedrive in 2016, Pipedrive was hosted in one data center in the US, obviously. GDPR was approaching, so we needed to come up with something that will help us comply. Besides that, our data center was growing too fast. We had incidents with large blast radius. We had performance issues from saturated network. We had a scaling issue because in a private cloud environment, you have to have a like reserved space next to your racks. So we embarked on this monumental project, what's called megaparsec. And why it is megaparsec? Because one parsec is an extremely long unit of length, and we saw this project as something that we didn't know when it's going to end. What did we do with megaparsec? This is a picture of how it appeared after megaparsec, but what did we do? We created a gateway service in front of Pipedrive, meaning which was aware of there being multiple Pipedrives and it being able to route traffic. We reworked a bunch of microservices for them to be multi-data center aware so that they know that where one customer or another customer is. We created what's called a management region, which helped us to take out like back office, migration tooling, and CI/CD from next to the other Pipedrive regions. And this is when we actually first started looking into hosting Pipedrive in AWS, because we were considering the second Pipedrive region at the time to be hosted in AWS. With megaparsec, we had created this like a region, Pipedrive region concept. But what is the difference between a region and a data center? So data center is a physical level of isolation, one site where you host Pipedrive. But this site can host multiple Pipedrives. But the region is a logical level of isolation where this region is hosted in one data center, and we can have now multiple product regions, which are like instances of Pipedrive or pods of Pipedrive in different locations, and also a management region, which is the place where we host internal tooling and migration tooling. This picture is a representation of one of our product regions. Currently we have 8. And these boxes themselves are a representation of the cost of each component. So the bigger the box, the more expensive the server. So these are servers. All right. So one very important thing to come out of this megaparsec was the migration tooling and the capability to do migrations between Pipedrive regions. There is another Medium article there, which describes this tooling. So let's imagine that we have 2 regions. We have a management region, and we have the migration tooling there in management region, which has agents in the product regions. Now, we want to migrate a customer from one region to another. We asked the microservices to do an export of their data about this customer into S3, and we then import that into the other side. But this is scale, like on a much larger scale. Currently there is over 100 microservices that have customer data in them. So we export, we import. If there is a failure, we delete the data again and later try again. But the fundamental thing here is that every single one of our microservices that is dealing with customer data or hosting customer data or storing customer data, it has import, export, and delete endpoints in their API path. This is our internal covenant. So Megaparsec was done. We created one new region with Megaparsec, we called it EU-Central 1 because we're new to AWS, but it wasn't in AWS, it was in Rackspace. We created this management region, which was in AWS. Then in the year 2020, we had, call it another pivotal moment where we reviewed the strategy of how we scale. We were growing, and we wanted to see what's next, or what's the correct way. So we had a choice of doing it in large data centers, like US and EU, and just grow them. Or we create more small ones. And we decided to go the second path. After that, we created second European region within the same data center, in the Rackspace data center, so then we had 3. We created the 4th one in the US. In 2022, we created our first pilot region in AWS, which was our attempt to see that is AWS equal, worse, better for our use case. And we later created another Rackspace region, so we ended up with 6. Now we are in 2022, and it's almost 10 years that Pipedrive had been hosted in Rackspace, and it had served its purpose. It's not a bad approach. But there were a couple of things that made us rethink, but maybe there is another way. There were issues, specific hardware issues, human-related issues. The cost of the private cloud is funky because you have to always consider there is a buffer. There are long hardware lead times, so you have to maintain a buffer always. So it takes 6 months for the servers to get there, so you have to always keep like 20, 25, 30% in reserve. There were limited data center locations, and the minimum size of one OpenStack deployment was quite large in terms of cost. The AWS pilot, which we called PDX1, it proved that the strategy that we were going towards, this more of the smaller regions, it worked. The new region had lower overall cost, it had faster servers, actually like we call them faster horses for some reason. More data center locations, obviously, and the tenant isolation for our customers was better, so blast radius smaller, and that means we started to look for options, what to do. Firstly, well, you don't go into the cloud just like that. You have to consider your options. In Rackspace, we had a long-term contract. It was a 3-year contract at the time. There was a fixed pricing model, and fixed means not like no broken and fixed. It's fixed means that it's very easy to forecast. Like this is the yearly cost done. Our data centers, remember, we had 4 of them. All the contracts of those data centers ended at the same time in one date. And Rackspace itself actually resells both private and public cloud, so as a consideration. AWS had for us these different acronyms that we needed to look into. So enterprise discount plans, which give you a discounted price for a commitment, or a growth commitment. It had a migration acceleration program, which gives you some money back that you add to AWS over like a year. There were private pricing addendums for S3 that gives you, again, a better price for a commitment. Reserved instances, savings plans, everything, right sizing. So a lot of things to explore before we arrived to any plan. So in the end of 2022, we had 1.5 years until the Rackspace deal that we had would have ended. So it ended in Q1 of 2024. So we started to now see, based on these considerations, that what do we do next, right? And we quickly came to a decision, no, well, we will move. We will move into AWS. And then we had to put together plans based on these conditions, that we have a good timeline, we have better financials, and we have, well, 100,000 customers to move. At the time, we had these 4 data centers, for 2 of them in the US, 2 of them in Europe, and these hosted 90% of our customers. 10% we had already moved with the pilot into AWS. And we created some plans. This plan shows that we migrate after the end of the contract, meaning the Rackspace cost goes up, AWS cost goes up, so we have a lot of cost. This plan is when we migrate before the end of the contract, so we start to ramp up AWS costs, Rackspace costs stay the same, double billing, a lot of it. Or we had some wishful thinking that maybe we can give back the Rackspace data centers like in a staggered format, and this was like, looked good, right? Good plan. And this is a list of plans showing that how many actually we made them. It didn't fit on the screenshot, so there were a lot more very detailed plans that we presented to our CFO and CTO. Okay, so we then came to understanding that without talking to Rackspace, we're not going to get anywhere. And we went to talk to them that, hey, we want to do this thing. And they helped us. We signed an agreement where Rackspace itself stays as the AWS reseller for Pipedrive. We signed a 3-year EDP with a discount percentage. We signed a 3-year PPA for S3, another discount percentage. And we were able to get this staggered plan from AWS, or from Rackspace. We actually gave away Rackspace hardware before the term. So here we are with AWS and Rackspace. Then we get to the migration of, well, contract was signed. We have to now move to this public cloud environment. And since we had developed this region-based architecture in Pipedrive, it allowed us to approach this migration in pieces, or like sections, or we call them stages. And to many different things, we found that the best length for one stage is a quarter. So during this migration stage, we built the infrastructure. We deployed Pipedrive services into this new infrastructure. We did a lot of testing. We migrated the customers. We usually did it like every day, small part, piece by piece. And then we decommissioned the source. This was the one stage of the migration. And again, 1 quarter, 1 stage. This is how the timeline example of one stage looks like. So we have 1 week for building infrastructure. We have 1 week of deploying services, 3 weeks of testing, a lot of testing again. Customer migrations, 5 weeks, then 2 weeks of buffer time, and another week in the end to decommission the old source. And since we signed the contract to be effective from 1st of April 23, and there were some conditions for us to grow during this contract, we built a plan so that we will be finished by the end of our Rackspace contract. We will do 1 test stage, we do 3 live stages, and the last Pipedrive customer was migrated on 17th of March to AWS. Out of this, on the previous slide, there was this buffer, and we used buffer only once. On the 3rd stage, we used 1 week for a buffer. So actually, it went quite good. Some facts, random facts about migration. We ran the migration activities, the actual movement of customer data over 90 days. We did 211 batches, and it took 250 hours end-to-end. 100,000 active customers. We call our customers companies, because our customers are companies usually, so we call them companies. In the import-export activities, there was 122 microservices. So imagine that in the source, for one company, 122 services have to make an export, and the target, in the target, they have to do the same import. We migrated 43 terabytes of customer data, so it's not bad. AWS accounts. Since we have this region approach or regional architecture, we also decided to spread out the accounts based on these regions. But since we moved from a rack space or a private cloud environment to a public cloud, we also, and in a lengthy manner, we had to come up with a way how to connect all of these regions. So we have, of course, our master payer account. We created a networking account, which has all of the network gateways between our Rackspace regions, our AWS regions, our offices, and everything. We had 8 accounts for our Pipedrive product region, so 4 of them in the EU and 4 of them in the US. And we had a bunch of others, so it's 23 accounts altogether in Pipedrive. And the infrastructure department controls and is responsible for the cost of them all, so all of the hosting. This is the map of our current Pipedrive product regions, and in the end there is the management region. And the customer accesses Pipedrive with the company name .pipedrive.com, and we route them using some fancy stuff in Cloudflare. This picture shows traffic over 1 week into Pipedrive app and over in the different regions. Each one is a different region. In the current cloud, we have 3,700 EC2 instances, about 22,000 virtual CPUs, 700 terabytes of disks, and 16 billion objects in S3. And Pipedrive gets about 3.3 billion requests every week. A very important topic when you move to AWS or are hosted in AWS is about savings and how you can be more optimal and economical. And a big part here is about compute reservations. How do you approach your reservation that your utilization needs to be at some fixed level? We used an RI or a reserved instance brokerage for a year before we migrated fully to AWS. We used a provider called Zesty, which helps you to buy and sell RIs on the market, buy one from the marketplace, sell to the marketplace based on how you use them. So it's like automation for RIs. When we signed the EDP, however, the realization came out that you can't have a discount on a discount, so you're not allowed to sell a discounted RIs when there's EDP on them. And we couldn't use Zesty anymore. But we were able to convert all of our RIs to savings plans together with AWS. And our coverage strategy is to be at about 70% covered by savings plans. What this section is about, what I call myself now FinOps, like we have DevOps and SecOps and other things, now we have FinOps in Pipedrive as well. So dealing with costs is my everyday work now, and constantly monitor, keep control. So we don't have a Wild West at all in AWS environment. It's purely controlled. Every movement is basically controlled. We look at changes every day, so there are reports about changes. We have Slack alerts about them. We have budgets for each account, and we have alerts based on those budgets. We have cost-related incidents. So if there is something happening with costs that's not planned, not forecasted, not budgeted, then we open up an incident. And since we have Rackspace as our reseller, our billing goes to Rackspace, so we also use Rackspace tooling to keep track of the costs. Newest thing we added lately, or AWS added lately, which we started to use, is anomaly detection, which about a week or 2 weeks ago, we found that some AWS had changed the runtime for some Lambda functions that we were using, and the code broke. And then the services started to iterate and iterate and iterate, and then we racked up like $6,000 for nothing based on that, so we had an incident and everything. But anomaly detection itself, it caught it. What were the key success levers for our project migration? First was the multi-data center or region-based architecture. This allowed us to approach the migration in pieces. So always you take a big thing, you break it to pieces, it's easier. We had existing tooling for migration, so we didn't have to create something new. Now, new software to do this movement, we just changed the oil in that tooling which we had already created. We had infrastructure as code, which helped us to recreate the environments with fair ease. A lot of our components are self-managed, so Kubernetes, databases, we don't use RDS at the moment, we use EC2s. So everything, not everything, but a lot of it was self-managed, so we were able to create it in AWS the same way as we used to do it in Rackspace, and we could do it also in Google Cloud or something else. We tried actually with Citic Telecom Cloud a couple of years ago, which was not successful. And we had a very strong team of Pipedrivers, our database engineers who very diligently performed all the migrations and planned them. Our SRE team, who was very adamant in controlling that there's high quality in the process. We have a system of tribes in Pipedrive, development tribes, who each own their own services. So we don't have ops and devs. We have those same people who wrote the services also be responsible for them. And they also were very strong during this process. So we had success. And that's it from me. The links there are to the same LinkedIn profile and the two Medium articles and the Medium itself. Thank you.
Alrighty, thank you so much. Do we now have a question? We do. So we have actually at least 3 or 4. So Agali, can you help? This gentleman in the first row was the first one.
Thank you. Christian, did you try to use spot instances for EC2 in AWS? Or are you using always, how it was, pre-saved or something like that?
Sorry, I didn't hear that well.
Did you try to use EC2 instances like spot instances?
Spot instances?
Yep.
Pipedrive uses spot instances. So I mentioned that we were using Pipedrive or AWS for a long time before we migrated the production. We use our data warehouse uses, and they use spot instances to some degree for batch processing. But for our production, like this, where we come from a private cloud which is very steady and very stable, the services themselves are very hard. They cannot cope with such change. So we hadn't tried that. Thank you.
Awesome. Next question. Do you have some problems with S3 API? I mean, cost of it.
Cost problems?
Yeah, because it's a bit expensive.
S3 API. We have had, since we also, as I mentioned, we have the Grafana stack, the LGTM stack in AWS. We hosted the storage is S3. We have had cases where some change brings about a lot of more cost than we actually planned. And also with our backups, because we store backups in S3, we changed at some point how we push them to AWS to S3, and it like changed the cost in API like 3 times or something. So we have had these issues.
Thank you. Next question.
Hi, I have a question. If for your migration, when you move from bare metal to cloud, did you modify your infrastructure to be a more cloud native directly, or you did like a shift and lift, and now you prepare to be more cloud native and more cost efficient on this way?
Yeah, so if we did a lift and shift, or we already brought it to be cloud native. So firstly, it wasn't bare metal. We just used yes, there was bare metal under it, but it was still a cloud environment because OpenStack is an open source cloud layer, basically like AWS API. But with that said, we did the lift and shift. And now since we come from a stable environment into an elastic environment, now we have this challenge of making it a lot more elastic than it was. So this is what we're trying to do now.
Thank you.
So I'm Denis from Pipedrive, but not infra. Did you have any advantages of rack space that you had, but now you don't have it with AWS?
We have a very strong team of infrastructure engineers. Romander is laughing. He helped the rack space himself a lot, so not really.
Since AWS has a big market share, not monopolies, but still the biggest one, don't we, or you afraid that AWS will increase their prices much, and then it will be like vendors stick?
Very good question. Do you actually know how many times AWS has raised their prices?
No idea.
Hmm?
No idea.
It has never changed. What they have done is they have created these new generations of infrastructure, these families of EC2 machines, that the new ones is just a bit more expensive, but you don't have to use it. But there's always this fright that the cloud costs will go up because somebody else also wants to make more money.
Two questions. Why do you still keep using Rackspace AWS, not just pure AWS?
It's not Rackspace AWS, it's just Rackspace resells AWS. It's many companies like Pipedrive itself has a reseller or channel sales model. So we use partners to sell Pipedrive. So AWS also use partners, and Rackspace is just one of the partners. And why we use Rackspace is purely because we were able to get a very good commercial agreement, which we couldn't have at that point because of our situation. We couldn't have received it direct at the time.
Okay, so money, nice.
Yeah, money.
But the second question, how much overhead does managing everything yourself actually cause you? Have you considered using more managed services now that you're in AWS?
I don't know exactly how much overhead. We haven't measured it specifically, but this is something we will explore going forward. We will see.
Mm-hmm.
We have a question here.
Can you pass it over there?
Thanks for the excellent presentation. A very big project and cool that you did it. I'm curious about the staff costs and the working hours that was spent on the project. What's the size of your team and in terms of infrastructure, and how big percentage of them worked on this project? You have day-to-day work as well. Mm-hmm. And did any estimate how many man hours were spent on the project?
Yes, so the infrastructure department is currently 25 people, as I mentioned, 6 of them database engineers, 7 of them infrastructure engineers, and some architects, network engineer, and observability. Since we had a lot of it already, like we had the building blocks, we had the migration tooling already beforehand, we had the infrastructure as code prepared because we were already running in AWS. So, and I also showed these stage sections or these works that we had to do. During each, there was some focus on one part of the company. So during the build, it was the infrastructure engineers who were building it, a bit of database engineers as well. Testing, it was usually the rest of the engineering work, like one person from each tribe was testing their services. During the migration, it was the only time when there was significant overtime because we did these migration jobs during out of hours of the customer. So we had different time zone customers and we did it out of their working hours. But with that said, we had the resources already, so the extra cost wasn't like significant itself. Maybe during that period it was 20 to 30% of the workload, but not more.
You mentioned that you did it by yourself without the help of a partner. Do you see yourself continuing that strategy, or are you looking for a partner? Or
at the moment, we'll continue as we are. We have been successful so far, and I just had a meeting today with Rackspace to review our costs, and every time they're very happy with us that we are a very good customer and manage everything ourselves quite well.
Cool, thanks.
Evgenia has a question.
Thank you, Christian. What is the future with the AWS and for infrastructure?
Future, first like short-term future is to become more elastic. We just enabled Kubernetes cluster level autoscaling again this week. This is firstly schedule-based autoscaling, but we will make it better with the help of Evgenia yourself. And next year we will try to look, or we will start looking into the option of using Graviton processors in our infrastructure. Currently, 1/3 of our infrastructure, as I mentioned, is MySQL databases, Percona MySQL, and there is no ARM version of that yet. But we're in contact with them through AWS as well, and then hope to have it at some point so we can start looking into that direction.
Thank you so much.
I think this is it from the audience, but I do believe that we have at least some questions in Slido, so move in the middle and let's see.
Where?
All right, so a question from Nikolai. Do you use EKS for Kubernetes on AWS Carpenter? How often update, in place update, or new cluster and migrate?
Okay, good question, and a perfectly logical one. Currently, for production work, for Pipedrive product workloads, we use our own self-built EKS, or not EKS, Kubernetes cluster, the vanilla Kubernetes cluster. But we have EKS workloads for many other things. So we have a huge and worthy of another talk system of dev boxes and test boxes, where we host environments for our developers, which is hosted in EKS, many EKS clusters. And we have EKS for our observability stack is hosted within EKS, and our other tooling like SecOps, security ops operations are hosted in EKS, and we do in-place upgrades. And we aim to do that in the future with our production workloads as well, and also with in-place upgrades.
And the last question for you. Budget per teams, what can you reveal about this?
Yes. So our teams, so we have budget per accounts, yes, as I showed. But for teams, because the teams themselves are very different in Pipedrive, there are, like, I don't know, maybe 12 development tribes, don't sue me for the number, but maybe 2 of them or 3 of them actually stand out in the hosting side. They have a significant part of the hosting components. The others are all hosted in the multi-tenanted environment or this Kubernetes. They have stateless services, and it doesn't really matter for them, or the cost is very small. But with the cost visibility and with bringing our infrastructure level metadata into the cost data, we actually are trying to get to that budget per team in the future.
So I lied. There are more questions to you. You said that big percentage of your infrastructure is MySQL, and you want to be more elastic. Do you plan to migrate to Aurora RDS? If yes, do you know how much will be the overall benefit?
No, we don't plan to migrate to Aurora RDS, and benefit from there probably is a benefit on the performance side, but the cost side there will be a large disadvantage compared to what we currently do with EC2s. We also our plan for the future is actually to bring the databases as much as possible into the Kubernetes environment and have them be elastic there.
Alrighty, so we will have the two last questions. Christian will be available for a chat a little bit later as well. You mentioned the 100 plus data holding services with 5-ish databases per customer. How is that structured?
So it all started a long time ago with this one schema per customer. We had all customer data in one location in a MySQL database in one schema. And nowadays that is still there, but at the same time there is lots of microservices that host their data in Elasticsearch or CouchDB or some other type of or flavor of MySQL. We have over 100 different types of MySQL schemas in Pipedrive. So the data is actually stored in many different types of microservices storages in the end. But what we started with was this one schema per customer. And what I meant by 5-ish, it means that there is currently 5 different services which have dedicated schema per customer, and the others have shared, like multi-tenanted systems where all of the customers are together in one database, in one schema, basically.
And the final question. LGTM stack is often called observability heaven internally, at least going there. What would be infra heaven, or at least the next few steps, keeping in mind that our customers are the developers?
Touchy. Damn. Touchy is one of my team members. What is the infrastructure heaven? Everything in Kubernetes. EKS, everything in EKS. Thank you.
Alrighty, I think Christian deserves a huge, huge applause. Thank you.
Thanks.
It's time to fuel our souls. So we are having a very small break, but please come back, and then we are having Tiit from Dynatrace talking some good things. Thank you. Welcome back.
Karlile. Karl oli mingi, no worries, ma kuulan juba nagunii läbi YouTube'i, aga ma tegin ühe pildi veel, mis ma arvan, sulle lihtsalt võib-olla niisama meeldiks ka.
Test.
See on see LinkedIni postitus, mida ma sulle enne ütlesin.
See, kus sa oled ekraanil ka samal ajal. See on väga hea kvaliteediga.
One, two, three, 1, 2, 3. 1, 1, 1, 1, 1, 1. One, 1, 1, 1, 1, 1.
Hello, hello, hello. I hope that everyone has grabbed a drink. Come back. Come back, please. Let's meet in the all hands area. Alrighty, I think a little bit about half of the people are already in the all hands area. I'm very super excited to welcome already on stage Deet. He is from Dynatrace, and he will now start sharing Dynatrace's experience with AWS. So please give him a very warm applause.
Okay, now it's working. Sure, yeah, so my name is Deet. Just to elaborate a bit about the introduction that was done, I'm not really talking about the Dynatrace experience, so even though I'm right now representing Dynatrace and I'm working there, I'm still talking about the overall threat hunting concept. We are creating tooling for that, how to analyze those kind of things and so on, but bear in mind I'm not here to make a product placement in my presentation or do some kind of selling event, so let's just skip to the threat hunting part if that makes sense for you. So if we're looking for a sales pitch, then yeah, you can go and grab a beer. This is not going to happen. So anyway, about me. My name is Deet, as mentioned. I have worked in cybersecurity or information security scene for over 15 years now, mainly being involved in financial sector or a public sector, and mainly dealt with logs or analytical part of it. So why I use quotes here? Well, when saying logs, we are not only talking about log analytics as an let's say, security incident management or detection or prevention or such things. We are also talking about fraud prevention, fraud detection, and all that kind of stuff that is in regards of logging or any kind of traces that are being left behind by any kind of user actions. So including internal auditing and such stuff, well, for me, everything like this is still logs. You are still analyzing and looking for anomalies there, and this is something that I have been focused for the past 15 years, mainly. I have a bachelor degree in IT software engineering, as Christian mentioned as well, where we studied together and then tried to get our first degree of real education as well. And on top of that, I have a master's degree in cybersecurity, where I put all those practical skills into practice in providing security measures in banking industry and so on. Why I'm talking about cloud today, or would it make sense to listen to me if I'm talking about cloud? Well, some of the institutions have given me accreditations about that as well. So since I'm holding a CISSP and the cloud security professional certificate, then I'm quite certain that I know what I'm talking about as well. So give me some credit in advance as well. Right now, talking or working in Dynatrace as a product management, so putting all those practical skills into a product, trying to make a world a better place for our customers as well. But as mentioned before as well, here not to sell a product, here to discuss about threat hunting. If you have any questions in regards of what I'm talking about, or if you have any questions in general, just raise your hand and ask. Otherwise, I will just forget what I was talking about and maybe you don't have any context later on. So feel free to just interrupt and say if you have something on your mind. Does that make sense? Awesome. So from here, when moving to cloud and talking from my own personal experience, not only from something gathered from books and definitely not from your experience, because everybody has their own unique experience, but from a security perspective. Then the main questions that usually that come to people's minds, especially in a highly governed sector like a banking industry might be, the first questions, of course, if we move to cloud, how will we get out? How much will it cost or how much money will we save if we migrate to cloud? What are the maintenance challenges? What are the user or IAM management challenges. How can we actually revoke access to cloud after the person has left the company and so on? Of course, GDPR. Of course, everybody's talking in any kind of blog posts and podcasts about new threat model. We are talking about new kind of attacks. We are not talking about DDoS anymore because this is AWS's problem. We are talking about attacking the application. And all those kind of things. There are lots of buzzwords, and I don't want to go into depth about those things. I would like to talk about the practical implications that are actually speaking towards me or my experience. So about having no perimeter, yeah, this is an issue definitely from security perspective, but maybe not from logging perspective or tracing perspective per se. So skipping to logs, what are the main issues when migrating to cloud? And I'm not saying that everybody will do those mistakes or everybody have done those mistakes. I'm talking about things that usually are not kept in mind while migrating. So if I'm talking about things that are basically basic knowledge for you guys, then sorry about that, but just maybe repeating those things makes sense for some of the people in the audience. And when talking about the forensic evidence, we are also talking about logs, events, traces, metrics, any kind of signal that leaves down a trace or that leaves down some kind of pattern that can be investigated further later on. If you're talking about forensic investigations, then by definition, this means that you can factually prove that something happened or something didn't happen. This is basically the idea of forensic investigation. And we're talking about cybersecurity and forensic investigations, and you're usually talking about analyzing logs or finding some evidence in logs, and you can actually understand what the attacker did in your system. So you might want to have those signals in place. This is why this is an issue. This is not only an issue in regards of incident management, this is also an issue in regards of threat hunting. So for example, if you don't have an incident, you haven't had a trigger, you haven't had a data leakage or some kind of press release that some data was stolen from you, you still might do some threat hunting. You might want to find something malicious before you have an indication of compromise. Some malicious activity, maybe an insider threat or whatever. This is basically something that happens before an incident is triggered. You might discover an incident based on that. But yeah, going maybe too far. So trying to now slow down. If I'm speaking too fastly, then just interrupt me again, because I have heard this story once before, which means that I know what I'm talking about, but maybe I'm skipping over some important parts, so just disrupt me. The four big issues that usually are forgotten is not maybe that people tend to forget when migrating to cloud, which sound really, well, understandable, but still. Cloud is not your infrastructure. Well, yeah, actually I do, yeah. This is a good point, because I have like a 4 fun already, so it's like... Okay, then I will show it like this. I will not start over if that's okay. I will just scroll through the slides if that makes sense. So I will grade that one later if it makes sense. So when talking about all the buzzwords, then I had this slide. Yeah, you remember that one? When I talked about myself, then I had this one, if that makes sense. Yeah. This was the disclaimer part that I discussed, okay? And here were the buzzwords, yes, and this is the forensic part. And the logs and the event, yeah, that's what, yeah. And now this is the part where you said that I didn't have slides. Okay. Are we on the same page, or should I start over? Cool. So, okay, sorry about the layout. I had beautiful pictures and the frame shouldn't be visible, but I will, yeah, let Prezi know that this works wonderfully with the team setup here. So, you don't own your infrastructure, which basically means that if you need logs at some point if you have the big incident, and if you want to have any kind of evidence that something happened, or if you want to find out if something happened, then the on-premise system that you had, the data center system that you had, or whatever kind of I own my network type of system that you had, you probably have your network span at least. You have your network logging it someplace, you have your infrastructure like DNS maybe, and other kind of base layers that might have some logging in place, if you have thought about those things, well, usually. In case of infrastructure as a service, you might not have them. And if you have an incident and you really need those logs, and then you turn to, let's say, AWS or whoever the vendor might be, they might have those logs at all, which might be a big issue, and oh, thanks, Sun Game Out, which might be a big issue at some point. The second big issue that we have experienced in some cases is you don't own the logs, which means that even if the service provider is providing you a service and they are logging then they log all tenants into one log file, basically, which means that they will never give you out their full logs just to analyze something if something happened. If you have a really severe incident, then you can contact the police department, you can have a court order or something like this, and they will analyze the logs on your behalf. But this basically means that you're trying to analyze logs blindly. Ask for a request, and they will respond to you, but you will not be able to analyze any logs by yourself. So these things should be thought through beforehand. You might not get the logs in time, which might be a jurisdictional difficulty. For example, if you are in EU and the logs are in US, then yeah, good luck finding those things out. If you are contacting a bulletproof hosting in Russia, yeah, you might as well not. You will not get those kind of things anyway, which means that you cannot be sure if any of those logs or traces or events are even existing in case of incident when you need them, and if you are starting to look for them, then, well, you most probably are too late to finding those things. And the log quality might not be sufficient. So in cases where we have actually had those kind of RFPs and stuff, and asked that, hey, you have a service, you're providing us the service, you're providing some kind of, I don't know, a good example, AWS S3, for example. If you take the documentation out and if you read or take the log samples, for example, then AWS S3 logs perfectly. All object accesses are logged, you have some events, and they are basically, well, seem quite okay, I would say. If, however, you go and read the documentation in detail, then you find out you don't have to read it. But basically what the story tells is that our logging for S3 buckets is best effort. We are logging if we can log something. The logs might be sent to you or gathered with a delay of a few hours or something, and they might not be complete at all. Which means that basically if you're only reading the headlines and you will migrate your, I don't know, public corporate website to S3, for example, you can do that in AWS. They have a use case for that, for example. And you are setting up any kind of environment in this kind of setup where you are using S3, and you're counting on analyzing the logs later on that you will get from S3, then it would be better if you consider these things as well. Which means that if you have an event in the logs, then the event happened. If you don't have the event in the logs, then it might have not happened, or it wasn't logged, or you didn't get the logs, or something forth, which means that logs are not 100% reliable. So again, I'm not saying it's a bad thing. I'm just saying that as a security analyst, you want to consider with those things as well. And now moving on to the topic at hand. So when we are talking, and again, I'm not saying that this is the only use case, or this is the best use case, or this is something that you have to consider, or that DNS tunneling is a really important thing that you have to keep in mind at all times. I'm just bringing an example based on DNS and based on AWS to show you where are the gaps and what to consider in any kind of service that you want to bring to cloud, because these questions are present in all the other services as well. They might be, they might not be, but still. Just a little explanation as well why I'm talking about DNS tunneling specifically. If I would be targeting a critical infrastructure service or a cloud service that is publicly accessible, and my goal is to exfiltrate data, then my first go-to channel of data exfiltration would be DNS. And there are a few reasons why this is. Usually, if you take a corporate environment, outgoing DNS requests are hardly ever blocked. They either are allowed directly to external DNS servers because it's simpler that way for the infrastructure guys, or they are accessible through your own DNS servers, which means that if you are requesting a DNS query or making a DNS query, then your recursive DNS will proxy the DNS requests to my malicious DNS server outside, which means that even if the connections on a network level are only allowed to your own recursive DNS, the traffic will still go through, because this is the DNS design. It has to go through, otherwise it will not get a response where the IP addresses are. There are countermeasures in place that you can have. Usually, let's say, whitelisting DNS queries, for example, not enabling DNS at all, having separate DNS servers for infrastructure as well, not the same DNS servers that are in your user land who want to navigate in and browse the web and so on, that has to be able to resolve names. Your data center services usually do not have to resolve all the names, but for some reason, most of them do still. Which means that, again, DNS is not whitelisted, not blocked, is accessible and has access to any kind of external server that is serving DNS usually. And the most interesting part for me, DNS is hardly ever logged. If you consider your Microsoft infrastructure, your corporate network, for example, you have your workstations, you are using Microsoft Active Directory, you're using DNS services from Active Directory or the DNS server that you have in this infrastructure. to enable workstation DNS logging in a central DNS server, you have to set it into debug mode, which will create much more load, for example, to then create these DNS requests to event logs, which means that these kind of things are not meant to log by design. This is a workaround. Yeah, sure, you can log DNS requests on a workstation level as well, but the workstation log transfer to a centralized server might not work and so on. So implications, but still, okay, let's skip it and let's go back to cloud. Same thing applies to cloud as well, because if you are, for example, considering even AWS, then by default, most of the logging is turned off. Well, that's understandable as well, because logging is really expensive, and logging is turned on only if a client wants the stuff to be logged. AWS won't log by default because of the same reason, I would say, otherwise the pricing label would be too high. But again, you as a customer, you might want to consider that enabling this kind of logging might make sense in certain places. And fourthly, or whatever, fifthly, why the DNS tunneling might be a really good case for stealing data. Usually the DNS logs are not analyzed as well, which means that, well, if you don't have logs, you have nothing to analyze. But I have heard really few cases where actually DNS query logs are being analyzed. And since they're not gathered, well, that's probably one of the answers as well. Yeah, I agree that the throughput there is quite small. You can send out with one query about like 190 bytes, but if you're stealing like credit card numbers or usernames and passwords or keys, for example, then with few queries you can do magic. Also, you can download stuff using, again, DNS queries with those TXT queries, for example, which fetch data. So if you are familiar with, let's say, SPF, for example, or DMARC or whatever, then they are serving all this kind of metadata or important data with the DXT responses, which means that basically you can have up to 12 kilobytes per one query as a response. So if you want to download malware with DNS, you can do that as well. Well, yeah, it has to be quite small malware, but still, if you want to have a larger one, then probably you will hit some kind of thresholds there, and that might create an alert. But if you consider just one DNS request that will send out the username and the password, or some kind of key, or get a response as a 12 kilobyte whatever, backdoor, for example, that will continue interacting over DNS, why not? That might work. Or, well, it has worked. Oh, also, fun fact, if you know how to do DNS tunneling, then if you consider the hotels in US, you can use internet for free because you don't have to go through the paywall, you can go around it because DNS works, even though web browsing doesn't. So, good thing to keep in mind. So anyway, just to do a quick demo as well to show what kind of evidence is then left behind in case of AWS and in case of DNS of an average setup that you might have. So what I have done, I have an AWS account, I have an AKS there, which is basically serving a Kubernetes cluster, and I have a custom application that is now divided between two nodes. So if you consider this kind of architectural view, it's something like this. So, to have a pointer here as well. Okay, sure. Showing with my finger then. So you have like two nodes. One is serving your services, other one is serving some as well. You have your core DNS pods, two of them with different IP addresses on one node, if that makes sense. This is important for later as well. If you know how Kubernetes is distributing the nodes or the pods between nodes, then you understand why this might happen, and I would say this is occasionally a standard setup of core DNS as well for some reason. Don't ask me why. So imagine now if you would execute, so basically what I'm doing, first of all, just to show you the setup that I have. These are the microservices that are basically running on my cluster. You can see the distribution between nodes here as well. I have 13 different microservices running on two clusters. So one is ending in 44, one is ending in 205. Now, if I would, I will execute 3 DNS requests on 3 different pods. Okay. That's even not important. I will just execute them and I will show what happens in logs. I think that the command line is not maybe that important. Oh, this is the TXT one. You see the response as well. That might be important as well later when we see the logs. So yeah, this is something that the server might respond to when you're asking something with the TXT query. Yeah, if that's familiar, then that's also good. So just executing an A record request and another A record request. So basically what was done, if I again show you the diagram, then I executed one DNS request here, one request here and 2 requests on this port here. And both of them are using this core DNS. Well, some of you that already know or have looked into VPC logging then know what happens, or if you're familiar how Kubernetes networking works, then you already know what will happen, but I will go through this anyway. So after executing the DNS queries, we now will look for the traces. So imagine that you didn't execute those things, but this port did it by themselves because they had malware or they had a backdoor or whatever they had. They tried to initiate some kind of DNS connection somewhere. If you would create some kind of detection scripts, then where would you start? You would start from networking. You would see whether some DNS or some ports have done some kind of DNS requests, and the easiest way to do that, of course, is to execute or view your VPC logs. So, for example, if you would open up your favorite log browser, VPC logs look something like this. You have your status, you have your source IP, you have your destination IP, your destination ports, or if you would take it into, let's just filter it out as well. I will just show you my ports, the ones that were executing stuff, and summarize those things by destination port as well. You see that that one port has accessed, well, those ports, which are basically bogus for us. The other port has accessed, well, now 6 times, my tests as well, sorry about that. The port 53 as well, which is DNS, and some 443 HTTPS port as well. I have no evidence in regards of the first port for some reason. Coming back to the diagram as well, if you're analyzing network logs in Kubernetes, and sorry if I'm talking about obvious things again, then VPC logs log all kinds of traffic that are going outside from your node to whichever kind of port or whichever kind of destination. It might be in the same cluster, it might be in the same, or the other node of the cluster, it might be some external service. Everything is written down to VPC logs. Things that are not written down to VPC logs are things that are happening within your node. If you know it, it's obvious. If you don't know it, that might be a surprise as well. Because if you read about AWS network logging, then you have those kind of things like packet source, and you have like some kind of other headers that can be added to things, which then tend to say that they log the real source IP address as well. The reality is that traffic within a node doesn't touch the wire, which means that VPC doesn't see it, which means that it's not logged. Which means that if you want to log networks or network traffic between ports as well, you have to resort into different things. If you are a security architect, for example, or you're a security planner, and you want to have network logs that are reliable, then you have to consider some kind of sidecarding here. Whether using Calico or whether using Istio or whatever the solution is, you have to have some kind of third-party tooling to enable pod logging on network level. You don't have to have it. You don't have to consider network layer at all. But if you want to have it, then please consider having some kind of additional things when migrating to cloud. Because when you're speaking about network security, if you want to speak about network security on that level as well. You might not want to do that as well because you can do any kind of stuff on network level, application level as well, so that's not an issue. But just to, again, keep in mind stuff. So again, but let's say that from the network level, we didn't discover much. The second point where to go is core DNS. Because if you would imagine, again, a DNS setup in a Kubernetes cluster, what happens is that pods are interacting with each other through DNS mainly. They are resolving the service names and get the pod IP addresses that are currently assigned to them. Because, pods have a life cycle, which means that pods can die. Their IP addresses can change relatively quickly, which means that DNS makes sense there. And core DNS is the go-to solution usually in Kubernetes. Kubernetes can log DNS queries, but again, you have to manually enable it. By default, they don't log basically anything. So, okay, let's now skip it and go into core DNS. When looking at the core DNS logs again, you can see that these things are again really cool in that sense that they have quite much information in it. I will just again skip to the right part or to the queries that are interesting to me. So, looking at the queries that were done, I will actually look at this one before. So this is the If I will now open up, for example, this query, then what I can see here, I can see that an quadruple A request, which is basically an IPv4 address request, was done towards this bbb.tithamalicious.domain.com. I see that, well, no response was gotten, and then I see this kind of information, which is quite reliable in case I want to detect any kind of, let's say, data that has moved out from my system. Yes? Yes, I have the magic button here. I think it's zoom in. And now I will just refresh it. Yeah, sorry. But I can keep on talking anyway without the picture as well. So, but basically what happens is that, you can see the query type, you can see the domain that was resolved with the subdomain that was resolved, and you see the response as well. Well, right now you basically see no error response, and you see the response size. But the issue here is, okay, this is really good because it actually shows you both of the IPs that have tried to resolve this node as well. Yeah, both of the IP addresses that have tried to resolve the domain are actually existing in core DNS logs, which means that core DNS is logging the queries perfectly. But for example, if you would have this TXT type of request that I did as well, then you might want to be interested in the results as well. Now again, what you might not read out from the documentation or what you might not discover before actually needing it is that core DNS cannot be logged or cannot be configured to log actually responses as well. So full result sets cannot be found from core DNS logs, unfortunately. Of course, yes, you can use, again, some kind of, I don't know, TCP dump or whatever kind of thing and read them out from the raw configuration, but this is an overhead. So what are the next steps that we can do? As you know, in AWS, all name resolution is done through route 53, which means that if core DNS doesn't know how to resolve a domain, for example, if it's an external domain, then it will result to route 53, which is the AWS service, which will then send the things out. Route 53 doesn't block anything. Route 53 doesn't block anything. It allows any kind of traffic going outside and inside. Yes? Yes, you can, yeah. But you have to do it. Yeah, you can define core DNS also not to resolve external IP addresses, but yeah. Sorry? Yes, yes. And this is perfect that you know that, because then it means that you have dealt with it or you are familiar with the technology and you know how to do it. The main issue is that you still have to do it, which means that if you are doing it, then this is perfect, and this is, I'm not addressing you at all. But usually what happens is that people set up their cluster, they're not configuring anything, and they will let it go as it is, and then wonder why accidents happen, and then say that AWS is to blame, for example. So it's not. It's a matter of configuration. You just cannot go into a service and then expect that everything will work out as it was on premise. So, but I totally agree with you. Everything in IT, most of the things can be achieved with a small amount of programming and configuration, so it's, yeah. So, yeah, route 53. So, but why not, if you have route 53 already, why not then use only route 53 logs? Because then you might have everything there. Yeah, we can see what happens there as well. Route 53 has a really cool log. So if you, for example, look at the log details, it basically logs down everything. It has a query name, which it is resolving, the type, the query class, basically, and the answers as well. Okay, this one doesn't have an answer. But if I would look, for example, let's filter out or remove the summarization here. If I would only look at the suspicious ones that I had, then, for example, okay, this one had an empty answer as well. Yeah, here is an answer one. So, for example, if you are making a request from any kind of pod in your Kubernetes cluster that is having some kind of answer, then Route 53 is generous enough to actually log down the answers as well. So, as you see here, you have your response data, which means that if I made an A record request, then I will see as a response data, I see the IP address that was actually requested. And for example, if I open up the TXT request that I had, the first one here, then in the answers, basically, I see the same kind of familiar song that was actually done or what was actually responded to me, which seems that this is a really good solution. I will just have to log down now only my Route 53 logs. And here is a trick. If you look at the Route 53 logs, or if you only imagine the whole name resolution part from a networking perspective, then what happens, I will show you the schematics again, what happens on the edge of a node is a network address translation, which or basically not, okay, this is one thing, but what happens in the core DNS part is that requests that are coming into core DNS are going out with a core DNS source IP address, which also means that if you are now looking at those requests that are present in your Route 53 logs, and you look at the source IP addresses, then in source addresses, you don't see the pod address anymore. You see only the 1099 address. And if you look at the schematics, you see that the 1099 is one of the core DNS server IP addresses, which basically means that if you are only relying on the Route 53 logs, then you see that, yeah, this one DNS server has done something suspicious. It has tried to exfiltrate some data, or some DNS tunneling attempts have been done through this DNS server, but you still don't have any indication about which pod did it. So if you imagine your nodes having like a multitude of different pods, then finding the pod that was compromised is still quite hard, firstly. And secondly, you don't still have any, even if you have core DNS logs and you have your Route 53 logs, then correlating those logs, especially if you have high amounts of DNS traffic, is quite hard because you don't have a common denominator or a trace ID or whatever to actually put those things together. So again, you can do it. You can make some assumptions, you can make some estimations, then you can find out some kind of correlation abilities there, like timestamping and so on, or some other trickery that, yeah, we don't have to go into too much details. But it's still something that you have to consider beforehand. It's not like that you are just only enabling logging in some places and configuring something and then hoping that you have the full data. You might want to try those things out in practice and create those kind of trace IDs for yourself, or at least know what kind of data are you lacking in case of an incident, so you don't spend your time doing your investigation on partial data, for example, which is also a good thing. You know that you don't trust those certain logs and you don't go into those investigations at all. You have to have a back route for that, if that makes sense. So everybody is so quiet. It's like 3 opportunities that are possible here. Everybody is waiting to get out to the sun, or everything is clear, or nothing is clear anymore. So. Yeah, the DNS offering will come in 2 years. So yeah. Okay. But anyway, I understand that I rushed through these things maybe too pacily or spoke too fastly. So if you have any questions later, then definitely we can target those. But if I would have to bring out the specific learnings of those use cases, or explain what is the thing to take away from this, then in case of logging by default, what I would remember is this slide. By default, VPC logging is not enabled, so you have to enable it manually. VPC logs do not contain inner node traffic in case of Kubernetes, which means that you cannot rely only on VPC logs if you want to consider network logging at all. And you have to understand that VPC logs are aggregated if you're logging them, which means that basically you don't have like, it's still a flow log. It's aggregated. It's not like one-to-one. You don't have all the packets there listed basically, but it also means that you will get it with a delay. So for example, if you have enabled 10-minute aggregation window for your VPC logs, then this means that you will get an indication about your network traffic after 10 minutes has passed. Then the logs will be saved, and then they will be forwarded wherever you want to forward them and so on, which means that if you want to do any kind of online detection, the 10 minutes is also already lost in aggregation if you want to consider that. So you might want to have some kind of faster ability to detect stuff. If you don't, it doesn't really matter. You can do post factum as well on the flow logs, and you will save a ton of money on persisting logs, for example. In case of core DNS, again, logging is not enabled by default, and core DNS logs do not contain DNS response, which is something to consider. And thirdly, Route 53, again, not enabled by default. You have to enable it manually, and does not contain the query source IP if it's a pod. It only logs down the requests that are coming into Route 53 itself, which means that it has to be a direct client of that, not like pass-through of any of the other recursive DNS servers, if that makes sense. So if you put it together, and just to comment, and this is not a comprehensive thing that is lacking in case of this use case as well. These are only the preliminary findings of one use case that we did, and I wanted to share it just to raise awareness that these kind of hands-on experiences on real logs have to be done. Otherwise, you might get misled by the documentation or whatever resources that you're planning on your clouds on, if that makes sense. Yeah. So yeah, takeaway or bringing it all together or making a knot on top of it or a bow. Detection and forensic investigations require data. Your incident will happen anyway. It only takes time. And you might not detect it, which is a good thing, or maybe not, depending on your industry. But not all incidents are coming out to daylight today. They might be coming out in 10 years, or they might not come out at all, which means that there might not be nothing to investigate. You will not get an indication that, hey, start your investigation. You will not have a body lying to start fingerprinting it. You might want to do your investigation beforehand. To be ready for those things, scenario-based security modeling helps a lot. By what I mean by scenario-based threat modeling is the same thing that I tried to explain ruggedly. Think of a way how an attacker might attack you, mock that attack, and see what kind of traces should be left behind. And if you're mocking those things and you do your threat modeling based on those scenarios, not an overall thing, do I have logging, do I have some kind of flows, do I have something else, do scenario-based really deep dive. And if you find out that all the logs are present, good for you. Mark it down and document it and then try to test it out and then see if the log quality remains. This can also be done on an application layer later on. Do you have the user's names? Do you have the source IPs of a customer? Do you have your customer IP moving in headers to your backend services and so on? So these kind of things should be actually mocked and tested out. Otherwise, you might lack the evidence in case of a real incident. And then it's too late to add those IP addresses to your headers. And yeah, practical testing of those scenarios and making sure you have these resources. You have the scripts developed, you have those logs in place, and you know how to find those logs or where to get those logs before the big incident. Because if you're already having an incident, then it's too late. Then you will not get those logs. I can guarantee you that. And with that, I would like to end my presentation. So thank you. And also, we have the careers page, which I added here, listening that others had it as well. So we are looking for 4 people in Tallinn. We are looking for 200 people in the whole Europe. So please come and join, look at the vacancies. And if you want to join us, then you can always have a place in Tallinn Lab as well. You don't have to go to Linz to get a job. If you see a vacancy there, that suits you. So just contact us in that regard. And it was taken down. Cool. Thanks.
Do we have questions? We have. Go ahead.
No.
Agali, can you help us? Sorry, 1 second. But if not... I have the same question as the first question there. Sorry, wait a second.
Hello? Oh,
yeah.
Jesus. So I'm going to repeat the question that's on Slido. What was that log browser? What was the logging language? If you could show us it again.
Yeah, definitely. I can do a 2-hour demo if you want. But basically, the query language that I showed, this was Dynatrace query language, which is the query language that we provide with the tooling that we have. Basically, it's blazing fast and blazing flexible to actually fetch data from your raw files while defining the pattern or the schema of your logs on the fly. So imagine having a security data lake that contains like 200 terabytes of data with various different formats which is changing on a daily basis. Let's say Office 365 logs that are changing on a weekly basis. And you now have an incident. Then what you can do is you can fetch the raw files or the raw logs with Dynatrace query language and parse it out or parse out parts of the log record that are interesting to you. So for example, if you want to parse out only usernames and IP addresses from a log source, you define the pattern on the fly and we will just apply it. You don't have to index it, you don't have to ingest it with a schema, you just have a raw record and then fetch it on the read. And it's really fast. I can seriously, if you want, I can demo it, but it will take some time to prepare it, so it's, yeah.
Do we have another question? We do.
Oh, and sorry, and the tooling, of course. And the tool itself was Security Investigator. This is also something that we have developed for the security offering. But again, we can do a separate demo on that as well. Best tool ever, yeah. So until you get your mic working, I can keep on talking about Dynatrace. Oh, okay, sure.
Pam, pam. So I'm responsible for DNS and Pipedrive, and I have a lot of questions actually here. But it looks like it's not a bit finished presentation, because, okay, I have several gigabytes of data on every DNS server, which we have like 50, and so per day. And what's next? So what to do with the data? You cannot analyze it like manually, or if you have some machine analyzing, then even if there would be like 001 false positives, then it would be a lot of alerts for you. What to do?
So I have a really good excuse right now. The mic works really poorly, so I'm not sure if I got the question. But if did I understand you correctly that you asked that if you have like a multitude of DNS servers and everybody is logging everything, and you now want to understand what to do with all those logs if you have them, basically. Oh yeah, that's an easy one. So analyze them. Basically, what you want to do, you have like, for example, again, as I described, a scenario-based approach. So if you are looking for any kind of malicious traffic from DNS logs, then there are like certain scenarios that you might want to test out. You want to test out for big responses. You want to test out for really unique domain names that are being resolved. You want to test out for a multitude of subdomains resolved for one new domain that hasn't been seen before. So these kind of automations and these kind of scenarios can be thought out, and then you can create a really simple script. Whether you use Dynatrace query language or you use Ruby or you use Python or whatever, you can basically just script out your scenarios and then execute them either automatically on daily basis, on hourly basis, whatever your risk appetite is, or you just run them once a month to see your compliance report and see whether your posture management is okay. but basically what you can do, you have to think about the things that are interesting to you and then start analyzing them based on your own scenarios. There is no like a silver bullet, otherwise AWS would do it for you already. So yeah, you have to think about your own scenarios in that sense. But again, probably we can help with that as well if you have interest towards that. So, sure, yeah. Sorry, I don't hear.
Yep. He can just limit DNS response from server to 500 bytes. That will be enough if they not use special cases like TXT, SPF, or DMARC records. It will solve issue.
Yeah, absolutely, definitely. So I would even say that, yeah, so one solution is that. I would say that my go-to solution would be to just disable DNS at all in certain cases. No, seriously, because if you have like, you have your inner cluster solution ready, for example, you have only so many services that actually require external DNS to work. And they're usually, if you have like the same kind of setup that I showed you before, with 13 different microservices that are interacting with each other and asking stuff from each other, there are only so many services that actually have to have any kind of external communication with any external party, which means that why do you resolve DNS at all externally? So just close it if you don't need it. If you start making thresholds, 500 bytes, 400 bytes, 250 bytes, then you can shoot yourself in the leg at some point because your real traffic might not get by anyway, but you might want to only leave the certain services that require DNS working with a really high limit, but put some other forensic capabilities on top of it that detect malicious activities or whatever kind of thing. For example, unique domains. Just prohibit some domains to be resolved. Or whitelist your domains if your services only access some known domain lists and create alerting on new domains or whatever. There are so many different opportunities to do, but you just have to figure out what is the best detection script for your company because it highly depends on the use case and the architecture and the design and so on. But yeah, design can be changed depending on the use case. Did I answer your question? You as well?
Do we have more questions? On the screen, okay. So, VPC logging can have an impact in CloudWatch costs. What is your trick to mitigate that, at some extent at least?
Yeah, great question. This question is totally out of the scope of this presentation, but thank you for the question.
All right, I think Tiit is about to finish his presentation. So let's give him a little bit of love and give him an applause.
Thank you.
I'm I'm sure Tiit will answer some questions later, but now I'm really excited to invite a surprise guest on stage. So hello, Toomas from Wise.
Can you hear me all? No? Yeah. Let me see how this works. Do we have this? Oh, yeah. So yeah, thanks, Tiit. I'm going to continue on the topic of logging. And yeah, I'm going to talk about logging beyond network boundaries and embracing the power of SNS and SQS. I'm going through some of the problems we've had with a logging setup, a solution, and how and why we think the solution fits our needs. Yep. A little bit about myself. My name is Toomas Ormisson. I'm a staff engineer in Wise, originally from Pärnu, and I've been living in the UK for past 6 years now, and 4.5 of which I've been building the observability platform in Wise. And before moving to the UK, I was working in Telia and working on metrics and logging systems there. A little about the Wise as well. Wise is a global technology company building the best way to manage the world's money. We're powering money for people, businesses to pay, get paid, spend in any currency, wherever you are, whatever you're doing. Co-founded by Kristo Käärmann and Taavet Hindrikus, and launched in 2011 under the name TransferWise. And we're one of the world's fastest growing profitable tech companies and listed on the London Stock Exchange. And yeah, what people are saying about us, we're trying to solve the world money problem, and we've made some great progress on fixing the international money transfers, and we're building the Wise account, which transforms the international banking. And having created this new infrastructure, we're now opening up for banks and businesses to build upon. And some numbers from 2023 about us as well. So in 2023, we had 10 million active customers worldwide, and we supported around 5% of the personal cross-border payment volumes globally, and around 66% of our customers come to us via word of mouth. And now to the logging part. So in this picture, we can see an early iteration of how our logging setup in Wise looked like. We had our collection pipeline, where we took logs with Fluent Bit and pushed it to Kafka. From Kafka, we had different consumers, feature consumers, reading that data from Kafka and pushing it out for various different use cases. And there's a next iteration of this design as well. I cover a little bit about it in my talk, scaling observability beyond processing 50 terabytes of telemetry a day, that can be found from YouTube. Today, I'm focusing solely on the logging problem and third iteration of where we're solving some fundamental problem with the issues we had around Kafka-based solution. So when writing logs to Kafka, we've made sure that all the logs that come from a single origin go to a specific Kafka partition. This was designed to make sure that logs arrive in the backend systems in order. So when you search for logs in Elasticsearch, they are in order. And it also meant we could ask questions like, where are my logs? Knowing which partition a service log belonged to has allowed us to attribute log lag and scope issues to specific services as well. If we think about how services log, different services log differently, and if one service logs are bound to a specific partition, this is what we'll end up with. We have hundreds of partitions with different levels of traffic going through them. We do the best we can with using multi-threaded setups, reading from these partitions, but you can only go so far with a setup like that. And the limitations we have around Logstash processing data is generally it is recommended to keep Logstash Java heap around 8 gigabytes, and that sets a limit on what we can do with our consumer. And on the Kafka side, we have a limitation that no consumer can subscribe, that no more than one consumer can subscribe to a single partition. So only one Logstash instance can actually subscribe to a single partition. So when we have a service that's generating more logs than we can consume in the other end, we start building up lag and having issues. And this is generally what it looks like when you have different levels of traffic going through different partitions. You end up in a situation where some of the worker nodes are working harder than others. And yeah, basically scaling a system like that isn't very efficient, and that was the main problem that we went to solve as well. Yeah, so basically we have diminishing returns when we scale this system. Another issue that prioritized this work was that in our new setup, we are not actually allowed to have direct connectivity from where we produce the logs to Elasticsearch, where we make them available to engineers. So our infrastructure and systems that send logs to us are usually separated by different network boundaries. And while we built our ingestion layer to be able to accept all of the logs from all of the environments we have, we are not really allowed to have outbound access to Elasticsearch. So we use Logstash and IAM roles to produce logs to an S3 bucket. And on the other side, we have another Logstash instance that takes the logs from S3 and writes them to Elasticsearch. And we control the access via IAM roles. And yeah, some of the requirements we had. So we must collect all logs covering our regulatory and compliance needs. In many cases, we must store these logs for multiple years, and our users should have logs available in a reasonable time so they can do their jobs. And does anyone know what this number means? The what? Yeah, really bad loan interest. That's a good point. This number represents S3 durability. Prize for you. Yeah, this is 11 nines of durability. This means that for every 1 billion objects in S3, you would likely go 100 years without losing a single one of them, single one of these objects. On top of that, S3 comes with 4 nines of availability promises for an object in a single year. And the solution that we've always needed to store logs for archival purposes, and we've always used S3 for that. But before, storing the logs in S3 was an afterthought. It was somewhere in the end, something was consuming that data from Kafka and pushing it into S3. Now that we had a system where we put S3 at the forefront because that's our requirements, that's what we need to be responsible for. And we brought that system to the forefront, S3 to the forefront of our problem. And yeah, the problem we had was load balancing data streams, and we ended up outsourcing that problem to AWS. And this is kind of what we came up with. So we still have our collection layer, different log producers sending us data. We collect that data in our new shiny infrastructure through Log Gateway, and we write that data to S3. So we also mirror that data that gets written to S3 to Grafana Loki, where we use it for real-time logging and making real-time logs accessible for engineers. For writing data to S3, we batch that data in 15-minute chunks or 100 megs compressed data, whichever comes first. So once that data gets uploaded to S3, We get an S3 object created notification, which we then send to simple notification service, where we have different topics. We have topic for EC2 nodes, we have topic for audit logs, and topic for Kubernetes services. And technically, we can have as many topics as we are willing to maintain. Like this is just a start. On the other end of that SNS topic, we have different consumers or different SQS queues, actually. And if we look at the audit log topic or audit log SNS topic, we can see that we have 2 SQS queues attached to it, and each of those queues has a unique consumer. So we track the lag for those consumers individually. And yeah, basically those security audit consumers, platform audit consumers take the data from their respective queues and write it into Elasticsearch, where it is available for engineers with a delay that we accept. Yeah, technically we could have a more simple solution where we wrote logs from log producers directly to S3, but it's a matter of trade-offs of what you want to do and maintain. And looking at the fit, so the major issue that prompted all of this engineering work was the hard limits we had in our design and being able to scale logging volumes effectively, scale writing that data to our backend systems. And if we look at our requirements again, we still have a pipeline that enables we now have a pipeline that enables us to replay any archival data we store. All our logs are still stored in S3, compressed in gzip format. That's been always the case, but now we have a little bit more flexibility. And on the analytics pipeline, we've added an artificial 15-minute delay, but we have real-time service offering with Grafana low-key. And yeah, this is basically the producer that accepts the logs and sends them to S3. The dashboard that I'm using here comes from Kubernetes Mixins. They provide dashboards, alerting rules, and recording rules. And you can see that the service accepting the log is quite well load balanced, and scaling a service like that is much more easier than scaling a service that I was showing before, where we have an imbalance. And yeah, and on the other end of this pipeline, we have another log stash service that listens to the SNS queue and gets the information about logs being uploaded to S3. Those notifications are less than kilobyte in size, so it's quite efficient as well. So in 1 kilobyte of information, you get information about logs that are 1 gig in size. So it's quite efficient in that regard. And yeah, we can see that our consumer compute utilization is quite balanced. And this is something we feel much more confident in scaling than what we had before. And yeah, we have better compute utilization. And yeah, this is it. 3 simple services helping us solve an engineering problem, optimize for cost and efficiency, and help us towards building a money without borders. Simple storage system, SNS, and simple queue service. This idea itself came from Andy from justeattakeaway.com. There's a blog post where he covers some of the technicalities, how something like this can be achieved, and you can find that blog post from this QR code. Thank you.
I have it. Yeah, sorry. We do have a question, so running to you.
I have a question about the format in S3. Why using gzip?
Why we're using gzip?
Yeah.
Because that's easy to do. Like we could upload raw logs, but those would be 10 times bigger we currently have around 2 petabytes of data in our log archive. If we multiply that by 10, we'd have 20 petabytes, and that's quite expensive. And technically, I've considered using something like Parquet, like we could upload everything in Parquet, but that again, I'm not sure what's the compression or what are the compression options for Parquet. But Parquet would be like you could use different tools to search.
You can use a compression algorithm other than gzip without using Parquet, like Rotli or ZSTD or Z-standard.
If we think about what formats the tools we use provide, gzip was just there and available. If we have other better options available, we're open to it, but we don't want to develop and maintain software necessarily. We want to keep our operational overhead as low as we can.
So the software you're using supports gzip already?
Yeah, like Logstash, it's just built in and it's easy to use.
Okay. You can add the support for Z-standard there. You would get some more benefits.
Sorry, I didn't get the last bit.
You can add support to Z-standard in the Logstash software itself. You could get more benefits that way, but just...
Okay, thank you.
Do we have more questions? Come on, people. Thomas is our surprise guest. No?
But yeah, if you're interested in...
We have one.
Yep.
Thank you, Thomas, for presentation. Can you please provide more info about SQSS? It's normal type of SQSS or it's a FIFA type? And FIFA SQS types.
The what?
FIFA type of SQSQ. Maybe. I'm not sure what you use.
I am not sure how we've configured it. I don't think we've put too much effort into it right now. I think it's first in, first out, yeah. But generally, it's scaling for any queues isn't really a problem anymore. But we haven't had to think about what kind of ordering we want to use, when we have logs going through our systems. But I know, there was a good talk on AWS conference in London recently that basically you can sideline some of the older logs to a separate queue and process them differently. There are options to deal with these things as well that come with AWS.
Yeah, thank you so much.
Alrighty, last chance. Does someone have a question? Slido? Alrighty, so let's go to Slido. I believe we have something over there. Do you still use Logstash and why? A question from Nikolai.
Yeah, we use Logstash, and why? We've tried different things. We tried using FluentBit instead of Logstash, but FluentBit didn't compress logs as well as we'd liked. And we're not religious about specific technology choices. We'll just use whatever makes sense at any given moment. Right now we use Logstash, and we also use FluentBit for other purposes. But yeah, hotel collectors are also option, but we need to know what problem we're solving with switching technologies. Have we tried? No, we haven't. Vector. Okay.
Have you hit AWS limits already, like total publish throughput for SNS per region or account?
Publish throughput for SNS we haven't, we're currently not running production workload on this, but what are the limits? The amount of messages we're pushing through isn't a lot. We're not pushing notification about every single log message. Every single message going into SNS is a combination of billions of, or millions of logs. There's 15 minutes or 100 megs of compressed data in that message. It's highly compressed. And I know Just Eat Takeaway, from what I've heard, runs their product on top of this solution as well. And I talked to Andy before starting to work on this as well, and they've been successfully running this kind of setup for years now.
And next question from Nikolai. Are developers happy with Loki comparing with Kibana?
That depends on a developer or depends on an engineer. I am happy. Not everyone is as happy using Loki as they are using Kibana. And that is why we still have Kibana around, because engineers like it. Although it is much, much, much more expensive than the LGTM stack is, like at least 10 times more expensive, if not more.
Why did you decide to build your own logging solution instead of using existing SaaS offerings like Dynatrace? This is going to be an interesting one. Go ahead.
Maybe Dynatrace wants to give us a quote, how long it, or how much it costs to send, I don't know, 50 terabytes of telemetry data a day, or 10 terabytes of logs a day. That's growing as well. But yeah, the answer is it's expensive. Like we're moving so much data that like that's the biggest opportunity, like tackling the quality of the data we're processing. Like that's the biggest opportunity right now. And like why haven't we gone with a SaaS provider? It comes down to a cost, right? And even if we send some data to a vendor, like let's say we say production only, we still need to maintain our shadow IT for everything else.
Has Wise considered using monitoring observability solutions instead of building their own solution?
I wouldn't say we're building our own solution. We're taking freely available tools that are open source, and we try to contribute back if and when we can. But like, we're not building any software. Like we're building systems with Lego blocks, like basically. We are very conscious about what it takes to maintain software solutions, and we try to keep our operational overhead to as low as we can keep it. And yeah, we haven't built our own observability system. Like we use freely available open source solutions.
Alrighty, this was our last question on Slido. Do we have one final question in the live audience? This is our final chance. No. Alrighty, so I'm sad to tell you that our meetup is kind of over, but the good news is that the most important part is about to start. So if you remember, I talked about gaining a little bit of weight. You're welcome. If you head to the kitchen now, you will see some pizza. So you're welcome to stay, mingle, ask the hard questions about Dynatrace and the very, very expensive pricing, and enjoy. So thank you for coming. Thank you for all the people online. Thank you, everyone.
Thank you. Ah.